This is the selection sort algorithm. I have these my original numbers 7, 4, 10, 8, 3, 1. I want to sort in ascending order using the selection sort. Now the way the selection sort works is start with the first element. See, these are subscript of my array 0, 1, 2, 3. Can go to as many elements as I want. So it take with first number 7. So it looks at 7. Is there a number less than 7? 4. So we run into 4. 4 happens to be less than 7. We go through the list. Is there a number less than 4? 10 is not less than, 8 is not less than, well 3 is less than 4. So I pick 3 now. Well, okay, is there enough? So I still have numbers to compare with. Is 3 less than 1? 1 is less than 3. So now I found 1 to be the list of the smallest number in this list. So I pick up 1 and 7, I swap them. See, 1 and 7. This is my first pass. So basically 1 is out of the picture. I put 10, 8 and 3. These are the rest of the numbers I have to go through. So basically I put the smallest number in its proper position. Now I'm going to go through the next. I pick up 4. So my index is now 1. So if you look at the for loop, is 10 less than 1? It's not. Okay, so 10 is not less than 4. Is 8 less than 4? Is 3 less than 4? Yes. So I pick 3. Now it's to be a small number. Then I want to go through the rest. Is 7 less than 3? No. So 3 happens to be the smallest number of the rest of the list. So I'm going to swap 3 and 4. So now I have 0 and 1 sorted. I copy the rest of the numbers. So this is my second pass. So in each pass, I will copy the next higher number. So I go through this with my pass. Now, index is now 2. So basically 1 and 3, I don't have to mess with that. So I pick up with 2. The index 2 is 10. Is 8 less than 10? Yes. Okay, so I'm going to take 8. Well, I need a number smaller than 8 for the rest. 4 is less than. So now 4 is the smallest so far. Then I compare with the rest. Is 7 less than 4? Nope. So I'm going to swap 4 with 10. See that? So now I have the third largest number, smallest number in its proper position. Now that's my third pass. Okay. So now I have these 3 numbers left. So is 8? I need a number smaller than 8. 10 is not less than. Well, 7 is. So I'm going to compare 7. I'm going to swap 7 and 8. So now I have 1, 3, 4. So this is 0, 1, 2, 3. And put my 10 there. So this is what I have so far. So my fourth pass, I have the 4th largest number. I mean in the order. Okay. Now I have 10 and 8. Well, 8 happens to be less than 10, so I'm going to swap 10 and 8. Okay. So 10 and 8 get swapped. Okay. So now this is my 5th pass. So I have 7 here, 4 here, 3, and then my index would be 0, 1, 2, 3, 4, 5. This is what I end up with. So now, this is my 5th pass. So accordingly, these numbers are sorted. So if I go back here, let me make sure this looks clear. So I end up with 1, 3, 4, 7, 8, and 10. So these numbers are sorted in ascending order. So that's it. So it's sorted in ascending order. Now, I did include some pseudocode or some code in there that's more looking towards Java, it doesn't matter the languages, I'm more concerned about the algorithm. I have two nested for loop. I have a nested for loop here, and I have another nested for loop. So for every I, j is going to start from I plus 1. So that means when I is 0, j is going to start at 1. So this says is a sub 1, okay, because I is 1, is a sub 1, which is 4. Less than, min is I, by the way. So min is 0, a sub 0. So is 4 less than 7? Yes. So now I'm going to put that index. Then j goes to 2. So you see, it's going through the rest and picking up the smallest number, which is the smallest index, which is going to be the value of min. Once this loop is gone, it goes through the other one. Well, I may end up swapping if needed. So if I swap this, that's going to go ahead and do the swapping, which is going to pick the smallest number, put it in temp, take that smallest index, put it in that position, temp, which was the value of I, that's my outer loop, and copy. So the swap is done. Now, if we look at this algorithm, this algorithm goes through it. I go through it 1, 2, 3, 4, 5 times. I go through it. So it's basically n minus 1. So I have 6 elements. So I'm going through it n minus 1. So if it's 6, I go through it 5. I have 199 times. So it is 2 nested for loop. So if this is n and this is n, basically I can say that's 1 and this is 1. So it's actually n times n, which is, if I add these up, I get n squared. So this is a big O of n squared. So this is known as the selection sort algorithm, and I included some partial code here so that you can trace through the algorithm and see how it works. And in terms of timing and all that, I'm using the big O. And that's the end of the selection sort, and thank you for watching.